This is the sixth tutorial of Classification Using Machine Learning and Introduction to Classifier series. In this tutorial, we will discuss the Naive Bayes Classifier and how to program it MATLAB by using the PR tools. Alright, let's begin. A Naive Bayes classifier, in short NB, is a popular example of a suboptimal classifier that uses a probabilistic algorithm for a classification task. Naive Bayes classifier works on the principles of conditional probability given by Bayes' rule. Let's take an example of tossing two coins. The possible outcomes will be two heads, head and tail, tail and head, or two tails. Based on this sample space, the probability to get two tails is 1 by 4. The probability to get at least one head is 3 by 4. The probability to get the second coin as tail given the first coin as head is 1 by 2. Similarly, the probability to get two tails given the first coin as tail is 1 by 2. You can notice that all attributes of a data point under consideration are independent of each other. In the next slide, you will see how Bayes' rule works. Bayes' rule gives the conditional probability of an event A given. Another event B has already occurred. According to this rule, conditional or posterior probability of a given B will be the multiplication of conditional probability of B given A, that is likelihood of an event to occur, and probability of event A, that is prior probability. This product can be defined as the probability of both A and B occurring. Then, this product is divided by probability of event B, that is evidence. You can observe that Bayes' rule allows you to update predicted probabilities of an event by incorporating new information. Now let's see how we determined the probabilities for the tossing two coins example. Simple probability is the ratio of the number of outcomes favorable for the event to the total number of possible outcomes. In the tossing two coin example, let's determine the simple probabilities by looking at the sample space. The probability to get two tails is 1 by 4. And, the probability to get at least one head is 3 by 4. Now, let's see how to calculate the conditional probability. Conditional probability for probability of A being true given that B is true can be represented as P of a bar B as shown in the slide. The probability to get second coin being tail given the first coin as head is 1 by 2. Similarly, the probability to get two tails given the first coin as tails is 1 by 2. In a small sample space, it is easy to calculate conditional probability directly, but in complex problems, Bayes' rule comes handy. Let's apply the Bayes' rule to calculate the probability of the second coin being tail given the first coin as head. Let A be the event that the second coin is tail, and B be the event that the first coin is head in the sample space shown in the slide. Probability of second coin being tail provided the first coin is head will be multiplication of probability of first coin being head provided the second coin is tail, that is 1 by 2, and the probability of second coin being tail, that is also 1 by 2. Now, this product is divided by the probability of first coin being head, that is 1 by 2. The answer comes out to be 0.5. Cool, isn't it simple to use? Some of the advantages of NB classifier are: it requires less training data, and it can handle both continuous and discrete data. It is highly scalable with the number of predictors and data points, and, at the same time, not sensitive to irrelevant features. Useful in real-time predictions, as it is fast to compute and easy to implement. NB classifier works well for classification problems such as face recognition, weather prediction, medical diagnosis, fake news classifications. Next, you will see how to use NB classifier using MATLAB PR tools. This slide shows MATLAB's PR tool method for the NB classifier. We recommend referring to the link provided in the video to learn to program the classification model using an NB classifier. The arguments provided to the method are: A is the dataset, N is the number of bins. This method returns the mapping function W. For any questions, please write your comment. Thank you for watching the video. Please subscribe to my channel and like the video.